For those of you who are just joining us now, welcome to the PALFINGER World Tour 2021 Marine Edition. My name is Marianne Evanstein, and it is my pleasure to be guiding you through today's expert talks. We'll be hearing from several PALFINGER marine experts who will share their insights on how the PALFINGER marine products and solutions take our clients' work to the next level, making it faster, more efficient, and safer.
Is a safe work environment essential to you? With our fully electric offshore cranes, we offer an innovative solution with the highest safety level in the market.
Our first expert talk will focus on offshore cranes, including the latest developments on the path towards more autonomous jib cranes. I'm now pleased to welcome our expert, Jan Zilgjerd. He is Head of Application Engineering, PALFINGER Marine Norway. And as you can see, he's not in the studio with us. He's joining us virtually from Norway in the town of Nesttun, which is near Bergen. So hello to you, Jan. It's great to see you up on the big screen here in the studio. Hello.
Hello, Mariana. Nice to see you as well.
So just tell us briefly what has been going on with offshore cranes.
We will show you first a short teaser about the vision we see in the future, bringing the operations to a safer level. Safety is always in the focus.
Snow, rain, rough seas, and gale force winds. The work must be done even under the toughest conditions. Safety is the first priority here. The safety of the employees, the safety of the load. PALFINGER offers new perspectives with remote control steering. The operator controls the system from a secure remote control center. Sensors and cameras provide him with all essential information in real time in order to carry out every job precisely and cost effectively, even in rough seas, in safety. Your challenge is our challenge. Challenge accepted.
So is it safe to say that we still have a long way to go before this vision becomes reality? Can you maybe tell us just where we are right now on this development journey, and also what will it take to achieve our goals?
There is still a way to go, yes. What I will do is that I will start with showing you the development of the fully electric cranes, which we did for Johan Sverdrup. Then I will take you through the next step, which was a Valhall development with further increasing safety with double luffing systems. And in the end, I will show you about the new type of crane we are developing for this environment. So the first slide here, you can see the contract we got for Equinor in 2015. We got a contract for developing 7 fully electric cranes for that oil field. They were going to be fully electric driven, lifting capacity about 60 ton, and a max outreach of 57 meters. They were designed to the highest level of safety according to NORSOC R002 and EN 13852. And also according to Equinor's technical requisitions. The focus when we did this design was high redundancy. We chose to select standard AC motors, and we also focused a lot on response time. I will show you later why. So the focus is always about safety. Then we can see the first step we did in this testing on the next slide is a test of the electric motor, because we had to show that this motor could turn rotation very, very fast. And that's because one of the most critical phases in an offshore lifting operation is when you're lifting towards a supply vessel. And if you're lifting full speed up to get off the vessel and you suddenly get entangled in the vessel, if you're not quick enough responding on the crane, then you might have a very dangerous situation where the crane is torn out to the sea. And in order to have this operation safe, the motor you can see in the picture here had to turn rotation very fast. It's a 140 kilowatt motor, and it weighs about 1 ton. So this motor have to turn very quickly from full speed one direction, about 3000 RPM, to full speed the other direction. And we will see the video now. You have to pay attention to the tape mark when it's turning. So if you are running the video, we will run it twice. So pay attention. You will see that it's turning within 0.5 seconds from full rotation one side to full rotation the other direction. And this was, nobody believed this was possible when we first said it could be done, and we did it here even faster than we initially thought we could do. After this testing, we will also show you a video of the installation on the Johan Sverdrup platform. We followed the testing for about 2 years in a test tower in our factory. And then we also did a full testing with a full load also there in the factory. In the movie now, you can see the installation which is done in Haugesund for these cranes. They were done at different locations, but there you can see that we are lifting them in a single piece being installed on the platform. It did some practice on the first ones, but for the last cranes that were lifted on board, we managed to do the installation within 5 days from start of lifting until we had a crane finally installed on the platform and commissioning was done together with Claes. So it was a very fast installation.
That does look very, very impressive, I have to say. So just wanted to ask then, what would you say, Jan, were the most important things that you learned during all those years of development and delivery of those cranes?
What we learned was that you always have to pay attention to the details. We thought we were going to have some more complications in the big tests, like this rotation of the motor, response time, and so on. But all of those big tests functioned exactly as planned. The problem was on the small details, like a micro switch and a brake. Those kind of things was gave us really some headaches. So that is the most important learning. So when the Johan Sverdrup field, as you can see in the background, is now in operation since 2019. It was delivered with 7 cranes and 9 free-fall lifeboats. So the small details is what we have to pay attention to.
And I mean, developing safe electric offshore cranes is, of course, a very significant milestone. So once that was achieved, then what was the next step?
The next step after this delivery was that we were in cooperation with Aker BP. They were replacing one of the offshore cranes on the Valhall field offshore Norway. And there, together with them, we have developed now similar crane as the one to Johan Sverdrup, but this is now with a double redundant lifting system. So it means that there is a very high safety towards the boom falling down, which is a quite critical situation if this happens. In addition, the crane was also equipped with an Optilift vision system, which is helping also increasing safety working towards the supply vessels. And we also delivered some traveling cranes, also with a double reeving system, making it possible to operate in a high-risk area. So both of these were more or less the first cranes delivered with these type of very high safety standards in the North Sea.
But can you tell us maybe why boom luffing system failure is more critical than hoisting rope failure?
This is a good question, and the reason for that is that if a hoisting rope breaks, you always know where the load is going to end up because you can follow predefined paths in your traveling when you move the load around on the installation. But the problem if a luffing rope breaks and the boom comes down, you will have a very uncontrolled movement. You don't know where finally the load will end up. So that might be in an area where this can have very critical consequences.
You mentioned that there's going to be some testing of this crane on the barge. Can you tell us a bit more about that?
Yeah, the barge, which is now in Norway, we will do testing of automatic sequences with this crane. So we are testing automatic hooking on and off, what you saw in the short teaser, and I will show you a bit later. We will test anti-pendulum functions. We will test different kind of support functions which will be necessary in order to make the path towards autonomous crane operations offshore possible. This is happening as we speak now. We just started last week this testing in Egersund in Norway, and it will continue until end of July when the crane goes offshore.
Well, I would assume that you probably had to do quite a bit of preparation before you were able to start operating such a big crane with automatic sequence control. Isn't that right?
That's fully correct. And we started actually this project in 2018 when we had a study together with Aker BP. We were looking at how we could solve these issues. So we used also an uplift camera, and we tested this in a small scale model, which is shown on the picture you can see on the right side here. We also worked on quite detailed risk assessments, also involving DNV-GL, the certifying authority. And we finally adapted the PLC software of the full offshore crane into the model in the first stage, and now also on the full-scale testing, which is going to happen in Egersund. We are working then seamlessly towards the Optilift control system, so that in the end, the Optilift system is giving the signals which the operator used to do in the past, so that the crane is now working more or less without interference from personnel. They are just being watched. So we will show you a video also now of the testing, which was done in Egersund, in Oslo, sorry. This is a test we did in Aker Solutions offices in Oslo. And we were running a full day with moving the container from, you can see it now moving on a supply boat deck, and it's automatically being connected. This container will then move from supply boat deck to the platform you see in the background, which was simulating a platform. And you could move it to different locations, and wherever it was, the crane can see the container, go down and connect it and move it to different locations. So this was a test which really showed the possibilities of this system, because nobody believed you could do this at this stage. And when we tested it and demonstrated it in this engineering office, it gave us a lot of attention. And people started at that moment to believe that maybe it can be possible in the future to do this kind of operation in an offshore environment. You can see the movements of the deck here. This is simulating a supply boat vessel motion, and it's taken from real recordings done in the North Sea environment, the way you see it here.
Well, it's clear that you did quite a bit of preparation to make this happen. So does this mean now you're confident that it's going to work when you start testing on the 60-ton crane?
Well, let's see. We already started 1 week ago, and we see there is some challenges, of course, but we are quite confident that with the team we have working on this, we will solve the challenges. But for sure, there will be many challenges still ahead of us, which we don't see, but I think we're in a good way.
Well, Jan, you mentioned also a new type of offshore crane, which was developed specifically for rough offshore conditions and remote operations. Can you tell us a little bit more about that?
Yes, this is the crane you can see now, which is designed with mostly unmanned installations in focus and less maintenance on the offshore environment. So what we have done is that we have taken all possible components and placed them inside, so you don't have anyone exposed to the outside weather environment. So it's based on a trolley traveling back and forth on a jib. And when you don't use it, you park the crane inside. So simple design have been the main focus to avoid complicating it more than needed. If we see a new feature and we're discussing if it's needed or not, we ask five times, is it really needed to add that component or function? One very interesting thing about this crane is that you don't have any luffing or boom motion. So that, together with it being a fully electric crane, also makes the power consumption very, very compatible compared to an electric normal crane or a diesel or electric hydraulic crane. So in the best case, you might come down to 50% or maybe even more reduction than that compared to a traditional crane. The crane is also, as you can see on this next slide, prepared for operation from remote location. Since there is then nobody to take care of the pre-check of the equipment, we also are working on having the crane checking itself before it starts operation, which is quite important that you know it's safe when it starts. And it's being, as we mentioned before, fully integrated with the Optilift support functions. And in the end, I will show you a bit more from this vision from a future unmanned installation, where you can see how it might look like in.
Jan, thank you so very much for this detailed and really interesting presentation, but do stand by because we have a couple of questions that our customers sent in for us ahead of time that we can ask you, beginning with a question that was sent in from somebody from actually Norway, so your country. This customer asks, when do you think we might see the first crane in operation offshore where these very important safety features are implemented?
This is, of course, being fully autonomous, we have still some way to go, but this is a step-by-step process. So the crane I just showed you for Valhall will be installed offshore in August, and we are planning early next year to start already offshore testing these functions. And maybe within 3 to 5 years, something like that, you might be very close to a real autonomous operation where you plan the operations ahead and the crane do them while the operator is just watching. So that is the hope, that it will go quite fast. But we are depending on partners which is really moving together with us, also class societies and third parties, because the rules is also not there for this at the moment.
So it always has to be a team effort, of course.
Yes.
All right, we have one more question sent in from a customer in the UK. And the question is, what advantages would there be in having goods transferred to an unmanned platform? I guess you would still require people to come on board to do the work anyway. So Jan, how would you answer that one?
And that is a good question, and I've heard that a few times before. And there is many advantages with that. You might start thinking about using the crane for different tasks which has not been used for before, like almost a robot with inspection equipment. But the biggest thing is also that you might bring in equipment at a time when you have a nice weather window. So you can have a boat going to different locations, you bring in the goods, and then when people are mobilized offshore, it's already in place. So you can save a lot on logistics, is the idea also behind this.
All right, Jan Silgjerd, Head of Application Engineering in Nesttun, Norway. We appreciate it so much. Thank you.
Thank you very much. And please be in contact with us if there's any questions.